Okay, so now we're going from solving for sides. Now we're going to go to solving for angles. I think that this is just a little bit more complicated. Not much, it's just not that bad, or it's not too bad. So if I look this right here, instead of solving for a side, we're solving for an angle. So basically, we know what the ratio is, we need to figure out which angle it is. I'm going to explain to you in terms of the table. So first off, here's my reference angle. Here's the angle I'm trying to find. We have my opposite and my adjacent, and we need to remember SO, CA, TOA. Okay, so the sine of my angle is going to be my opposite, which is 2.62, divided by my adjacent, which is 2.20. So I'm going to divide those out in this case. So 2.62 divided by 2.20, and I end up with the sine of the angle, the ratio of the opposite to the adjacent, when you divide the opposite side by the adjacent side of whatever this angle is, I get 1.1909. Okay, to 4 decimal places. And we talk about 4 decimal places for accuracy. Now, what we're doing is actually we're going to be working backwards. I'm being given the value in the trig table, and I have to go back and I have to find the angle. And so there's 2 ways of doing this, okay? My first way is the less accurate way, but I think it is a much more solid way to kind of get you to understand what you're doing. So it was 1.1909. It's kind of like similar to what we did before. So I look in tangent, and instead of looking at the angle and finding the ratio, now I'm looking at the ratio and trying to find the angle. So it says so it was 1.1909. So I look for something close to that. So 1.1909 is actually really close to 50 degrees. So I would say it's approximately, if I was just using my trig table, I would say it's got to be about 50 degrees, because 50 degrees has, if I divide the ratio of the opposite to the adjacent, I get approximately something close to that answer, okay? So if you go backwards in the table, that's what you would do. And so what I'd end up with is theta, okay, and this is actually the Greek letter theta. I should go over this. This is used for angles. And the reason why it's used for angles is we typically don't use x and y for angles, because those are actually coordinate measurements. Okay, x is actually how far left or right on the x-axis, and y is left or right on the y-axis. So when we talk about doing trigonometry in the coordinate plane, we had to actually have angles as a variable, name something different. So that's where we use the Greek letter theta. And so my angle was approximately 50 degrees. Okay, and so this isn't going to be as accurate as if we use a calculator. So I'm going to show you how to use the calculator. So I still have my sine of my angle is equal to 1.1909. Okay, what you're going to do is I want to just have my angle. I need to get my angle by itself. So what you're going to do is essentially you're going to do the inverse sine. And that's the equivalent of what we just did. So I'm going to actually take the inverse sine of both sides. Well, sine and inverse sine, they basically cancel each other out, for lack of a better term. And so what I'm left with, and this is what you're going to put in your calculator, is to find my angle is going to be equal to the inverse sine of 1.1909. Okay, so I go back to my handy dandy calculator. So it's 1.1909. Okay, and I do, in this case, I'm going to go to my function. So it isn't from your main, you don't use these, you have to use the inverse of ones, because instead of, so if you use sine, cosine, and tangent, it would be taking that as an angle, look up 1.1 degrees and it'd tell you what the tangent is. Well, we're telling you what the ratio is, you have to go back and find the angle. So it's going to be inverse tangent of 1.1909, there we go, 1.1909. And it's about 49.97 degrees, which is approximately 50. So we did a pretty good job in our trig table. The trig table actually did a pretty good job with that. So So approximately, which is approximately 50 degrees. So you see you essentially get the same answer. It just, this is going to be more precise. Okay, so we're just going to go through and we're going to find the angles when you know the sides, and it's basically the same thing that we were doing before. I'm going to show you something a little bit different. This is how I do it in the calculator. So here's my angle, here's my opposite, here's my adjacent. That's going to be TOA. So the tangent of my angle is going to be 13 over 34. I know, I just want to know what my angle is. So I know my angle, I'm actually going to be looking this ratio back up. And this is what I'm going to be putting in my calculator, just so I'm not carrying around these decimals. You can actually put the 13 over 34. You don't have to find that decimal first. And the nice thing about finding the 13 over 34, or putting that in, is then you don't have these crazy decimals. So I'm actually going to put this in here, and I'll show you. So it's going to be, we don't want to use it, we're doing inverse tangent of 13 over 34, and it's 20.92 degrees. And we'll go with to the nearest tenth. Sorry. So my angle is approximately 20, my brain's just not working today, 0.9 degrees. Okay, this one right here, here's my adjacent and my hypotenuse. So I'm going to use my cosine. So I know the cosine of my angle is going to be equal to my adjacent side, which is 25, over my hypotenuse, which is 32. So in order to find my angle, I find the inverse cosine of that ratio. Okay, and you can go through, put it in your calculator, and you get theta is approximately 38.6 degrees. And make sure you don't forget the degree symbol. Last one, this is opposite and hypotenuse, so that's going to be the sine of my angle is equal to 22 over 34. So my angle is going to be the inverse sine, because remember I'm working backwards through the table, of 22 over 34, which is approximately 40.3 degrees. And I use approximately because those are not precise measurements. So sometimes you will be given all three sides and you just pick your favorite trig ratio. Okay, I'm actually not going to do this one. I'm just going to do this one over here. So I'm fond of sine. I don't know why. This is my opposite and this is my hypotenuse. So I'm going to say the sine of my angle is equal to 30 over 50. And so my angle is going to be the inverse sine of 30 over 50. And it does not matter which one you get. So and you guys can check it. I'll have in class, we'll do this a little bit differently. And so my angle is going to be 36.9 degrees. Okay, so you just pick whatever ratio. And I don't think that we actually need to do the next one. All right, a couple word problems. This one may be something that you're not familiar with. So a 3.4, this should be foot guy wire. So you have a tree. It's actually not going to be that tall. Guy wire is attached to a tree 3 feet from the ground. Okay, so this is a short tree. So a guy wire is actually the wire that keeps a tree up. And so it's 3.4 feet, and it's here. It says, what is the angle formed between the wire and the ground to the nearest degree? Okay, so this is the angle. This is the opposite, this is the hypotenuse. So I'm going to say the sine of my angle is equal to 3 over 3.4. So my angle is going to be the inverse sine of 3 over 3.4, which is going to give me approximately, because it says to the nearest degree, is approximately 62 degrees. All right, we're going to do another one. 10-foot ladder. We like these ladder problems, don't we? So we have a 10-foot ladder, so I know the ladder is 10 feet, reaches a window that is 8 feet from the ground. Okay, what's the angle that's formed between the ladder and the wall? Okay, so we're trying to find this one right here. So this is the adjacent, this is the hypotenuse, so I'm going to be using ca or cosine. The cosine of my angle is equal to 8 over 10, so my angle is going to be equal to the inverse cosine of 8 over 10, which is going to be approximately 37 degrees. Okay, last idea is that concept of solving right triangles. So to solve a right triangle, you have to find all of the missing sides and all of the missing angles in your right triangle. So first off, the easiest thing for me right now is to find the measure of angle B. The measure of angle B, of course, is going to be 62 degrees. So the measure of angle B is equal to 62 degrees. Now I'm going to use trig to find my other sides. This is my hypotenuse. I'm going to use the angle that I know. This is the opposite. This is the adjacent. So I'm going to find the opposite first. I know that the sine of 28 is equal to BC over 7. So I can multiply each side by 7. And BC is approximately 3.29. And so I have my 3.29, and I'm not going to use the 3.29. I'm still going to be using the 7. So I'm actually going to be using, so this is my adjacent and my hypotenuse. So I'm going to be using cosine to find the other side. So the cosine of 28 is equal to AC over 7. Do the same thing, multiply by 7. And the distance from A to C is approximately 6.18. Okay. You can also solve a triangle, and again, you just need two things beyond, you need two pieces of information beyond the right angle in order to solve a triangle. So here we have the right angle, of course, but we need two pieces, and it doesn't matter which, as long as it's not two angles. Two angles is not enough information, so I need at least one side and an angle, or two sides and no angles. So for the next one, I have two of the sides. I need to find the third side. I'm actually going to use Pythagorean theorem to find the third side. So that's going to be 3 squared plus 10 squared is equal to AB squared. Sometimes that's still the best way. 9 plus 100 is equal to AB squared. 109 is equal to AB squared. AB is equal to the square root of 109. And it's asking for your answers to the nearest hundredth, and so that's going to be 10.44. And what you notice is that the smaller your angle is, the closer your largest side and your hypotenuse are going to be, for those of you that are kind of wondering. All right, so now I'm just going to solve for one angle, and once I solve for one angle, I actually can find the other one. So for this angle right here, I know that this is the opposite and this is the adjacent, so I'm going to use tangent. The tangent of angle B is equal to 3 over 10. So the measure, and this is one that we haven't done before because we keep using theta, so the measure of angle B is going to be the inverse tangent of 3 over 10. In other words, if this is the ratio, then I can find my angle. And so the inverse tangent of 3 over 10 is going to be, so the measure of angle B is equal to 16.70 degrees. Now you can use trig again to find the other angle, or you can subtract from 180, you're still going to get the same thing. So if I do the 180 minus 16.70 minus 90, I end up with the measure of angle A. So the measure of angle A is equal to 73.3 degrees. Okay, but you can also use the tangent of A. So the tangent of A, in this case, if we're talking about A, this side would be the opposite, this side would be the adjacent. So this would be 10 over 3. So the measure of angle A would be the inverse tangent of 10 over 3. And when you put that in your calculator, and actually it should be the nearest hundredth, so the measure of angle A is still going to be, when you round to the nearest hundredth,